Hi, welcome to my video on solve a system of linear equations, 3 variables, and solved by elimination, part 1. So we have a system here that I'm going to do for you. Notice this system got 3 equations, and we'll number the equations 1, 2, and 3. 3 equations has 3 variables, x, y, z, x, y, z, x, y, z, and the exponents are 1 for all of these variables, so it's a linear, degree 1. Select any pair of equations and eliminate a variable. So we're going to select equations 1 and 3 and eliminate z. The reason I'm eliminating z, because if you add these two, you get 0, and if you add these two, you get 0. And that doesn't happen with the x and y, so it's easier to do the z's. So equation 1 is x plus y plus z equals 3. And equation 3 is x plus y minus z equals 1. Draw a line, the z's cancel out, so 2x plus 2y equals 4. And this is the equation, that's 1, 2, 3, this is the new equation number 4. Now I have to pick another pair of equations and eliminate the same variable. So I did z here, I'm going to do z again. So now I'm going to pick 2 and 3. So equation 2 is 2x plus y plus z equals 4. Equation 3 is x plus y minus z equals 1. Z's cancel out when I add, I get 3x plus 2y equals 5. And this is equation 5. Now, there's a coincidence that this is a 4 going equation 4, this is a 5 going equation 5, but that's only a coincidence. This is 2 new equations, 4 and 5. Now we're going to solve these 2 equations. Notice I eliminated the z. That gives me a system with x and y, so which I'm used to doing. So let's write down equation number 4. 2x plus 2y equals 4, and 3x plus 2y equals 5. So now I want to eliminate, and it looks like the best one to eliminate is the y's because they're 2's. So I'll go negative 1 on that one, and a 1 on this one. And that gives me negative 1, gives me negative 2x minus 2y equals negative 4. Multiplying by 1 won't change it. And because I wanted to eliminate the y's cancel out, so I get x equals 1. So I got one of the values of x is 1. Now I can take the 1 and sub back into 4 or 5. So once you put a 1 in here and solve it, you only got y left. Or when you put 1 here, you only got a y left. So you can sub 1 for x into, so you can go into 4 or 5. So let's go into number 4. 2x plus 2y equals 4. So I'm putting 1 in for x, so x is 1. 2 times 1 is 2, right? So 2y equals 4 minus 2. 2y equals 2, divide by 2, and we get y equals 1. Now I have the value of x is 1, the value of y is 1, so I'm going to substitute the value that's in 3, which is 1, and the value that's in 2, which is 1, into either one of these 3 equations. So I'm going to take those 2 values of x and y and sub back up here, and that should give me the z value. So I'm going to sub 1 for x, 1 for y into number 1. So x plus y plus z equals 3. X is 1, y is 1. So 2 plus z equals 3. Z equals 3 minus 2. So z equals 1. So now we have x is 1, y is 1, z is 1. So the solution, x equals 1, y equals 1 and z equals 1. And again, we take those values and put it back into number 3 and check it. So you put 1 here and here and here, you get 2 minus 1 is 1, so we're okay. Or you can write them down as 1, 1, 1, because in these, it's an x, a y, and a z. Normally it's an x and a y, but the z is the third one. So you can write them down like that, or as an ordered pair. Okay, that's one explanation. Let's do another one. But the more we do, the better you get. So we have 3 equations, 3 variables, so we'll number them 1, 2, and 3. So pick a pair of equations, and it looks like you could, again, there's no difference here. That's a 2 and a 3, that's a 3 and a 5, 5 and a 2, 2 and a 7. Right here, again, I'm going to eliminate the z's. So I'm going to take equations 1 and 2 again. So 5x plus 2y. So that's equation 1 written down. Equation 2 is going to go down below it. So now I'm eliminating the z. So that's a 4. I need a negative 4 here, so I'll multiply this one by 2. Because 2 times negative 2 gives me negative 4. Multiply this one by 1. Multiplying by 1 does not change the equation. Multiplying by 2, I get 4x minus 6y minus 4z equals negative 26. 4, negative 6, negative 4, negative 26. The reason I did that is just to check. Make sure z's are gone. So I get 9x minus 4y equals negative 21. So this is a new equation. I'm going to call it number 4. So now I got to eliminate. So I eliminated z once, so I'm going to eliminate z again. The best pair to pick is 2. That's already a negative and positive, so multiply by 3. Multiply by 2 gives you negative 6 and 6. So I'm going to pick equation 2 and 3. So let's write down number 2. Let's write down number 3. Just got to be careful. Write them down. So 2, negative 3, negative 2, negative 2, negative 3, negative, perfect. 7, 5, 3, 11, 7, 5, 3, 11. And I'm going to multiply this one by 3 and this one by 2. The reason you do that, because I'm eliminating the z's again. 3 times gives me 6x minus 9y minus, gotta be careful, 6z equals negative 39. So 3 is a 6, negative 9, negative 6, negative 39. Multiplied by 2 gives me 14 plus 10 plus 6z equals 22. And we draw a line and we cancel. We get 20x plus y equals negative 17. So we'll call this number 5. There's 2 new equations. So we take those 2 equations, which is 4 and 5, and write them down below each other. So because I'm going to eliminate, when I look at them closely, they're all lined up. Notice I took the 2 equations, I put them here, put the numbers in, and I went sideways. Got an equation. Then I wrote the next 2 down, put them here, and I multiplied and went sideways. So I keep utilizing my space. So now I'm going to multiply these. Looks like I'm going to eliminate. Notice a 4. I need a 4 here, and I multiply this by 1. So that's 9x minus 4y. And 4 gives me 80 plus 4y plus, and that gives me a negative 68. Add, the y's are gone. 89x equals negative 89. Divide, x equals 1. So I got x equals, whoops, be careful, negative 1. Now I'm going to sub that into, I'm going to sub negative 1 for x into, pick an equation, and it looks like I can put it, this is the better one, because when I put it in here, I got one little y. So I'm going to put it into 5. So write down number 5. So notice I have x is a 20, x is negative 1, y has no coefficient in front of it, or numerical coefficient, so it's easy. Move it 20 over, make it positive, so y is 3. So now I got x and y, so I'm going to sub negative 1 for x and 3 for y into, I got two variables, so I'll go up into the top, and since these are all positives, I could pick any one, but I'm going to pick this one because they're all positives, so I'm going to go into number 1. So 5x plus 2y plus 4z equals 5. There's number 1 written down. So x is negative 1, y is 3. So I need to solve to get z. Multiply first. Negative 5, 6. That's a 1. I simplified this. Rather than move the two of them over, which are good, I added them up first to get 1. Now it's easier. If you simplify each side first, it's easier. There's less to transpose and less chance of an error. Divide by 4, z equals 1. So the answer, or solution, is, you could do an ordered pair. X is negative 1, y is 3, z is 1. Check with your teacher. Or you can go x is negative 1, y is 3, z is 1. Hopefully you can see the pattern I'm trying to establish. And let's go again. Let's see another one to do. Which one do we want to eliminate this time? And notice there's no, again, the z, I got negative 3 and 3, so let's do the z's again. So I'm going to do 2 and 3 first. So 2x plus 2y minus 3z equals 1. 3 is negative 2x minus y plus 3z equals negative 5. Notice I did the z first because they were automatically going to cancel. Done. So 1 and negative 2, negative x. 2 and negative 1 is a y equals negative 4. So this is number 4. Now, which pair do I want to take now? Again, this is negative and positive, so I'm going to take 1 and 3. 1 and 3. 1, 3x plus 4y. Again, I repeat, it just takes time to work this out, so you don't have too many of these on a test, but they are valuable to do. So I got 3, 4, negative 5, 3, and I got a negative 2, negative 1, 3, negative 5, perfect. And I'm eliminating the z here, so the z is going again. So that's a 3, and multiply this one by 5. Notice I picked these two because they're already plus minus. So 3 times all of these is 9x plus 12y minus 15z equals 9. Multiply by 5, I get a negative 10x minus 5y plus 15z equals negative 25. If I add, cancels, and I get negative x plus 7y equals negative, and that's negative 16. This is number 5. So now that I have z gone, I'm going to take these two equations, write them down below each other. This is equation number 4. This is equation number 5. There they are. Negative, positive 4, yep. Negative x, 7, 16, perfect. And looks like I'm going to multiply it. That's a negative 1. I'm going to multiply this one by negative 1. Multiply this one by 1. That eliminate the x's. X minus y equals 4. Multiply by 1. Negative x plus 7y equals negative 16. And the x's are gone, so I get 6y equals negative 12. So that means y equals negative 2. So this time it was easier to eliminate the x. So I got y first. So now I'm going to sub negative 2 for y into. So I'm going to sub back into 4 or 5. So I can sub back into, let's go back into number 4. Seems to be smaller numbers. So this is equation 4. I'm subbing y as negative 2. So move the 2 over to become positive. Negative x equals negative 2. Divided by negative 1. X is 2. Now I have y is negative 2. X is 2. So I'm going to sub x. I'm going to sub 2 for x and negative 2 for y into. So, which equation do you want to go into? Well, the smaller numbers is number 2. And I could number these just to make sure you know what I'm talking about. That's the number 3. So I'm going to go into number 2. So number 2 is x plus 2y minus 3z equals 1. So x is 2, y is negative 2. So you see why I do eliminate z, because everything works nicely. If you eliminate z twice, you get 2 equations, 4 and 5, that eliminate the x and y that you're used to. Then when you solve and get a value, you plug that into 4 or 5 to get what x is, because this is what you're used to. This right here is what you're used to. Then when you get to 2 of these values in x and y, you go back into one of these, you get the z. So that's a good pattern. And you add these up. It just so we have all 3 answers. So again, the solution, and if you want to put the x is 2, and the y is negative 2, and the z is negative 1. Remember, it's an x, y, z, like an x, y, and an or period now is an x, y, z. Or you can write them all down and say x is 2, y is negative 2, and z is negative 1. So your choice to name it like this or this. And lo and behold, one more to make sure you can see what we're doing, follow the pattern. So we have 3 equations. X, Y, Z, and they're linear because all degrees are 1. So which variable do you want to eliminate? So the best one I see that the x's are plus and minus 1, so I'm going to eliminate the x. So I'm going to pick equations 1 and 2 and eliminate the x. The x is the easier. So even though I said to do z is better, but let's try it with eliminating the x. Reason? because when you add these two, you get 0. When you add these two, you get 0. So the x is gone. So 4y plus 4z equals 12. That's equation 4. And now when you write down equations, let's see, I'm going to write down equations 2 and 3. Number 2 is negative x plus 3y plus 3z. And number 3 is x. Just be careful in writing them down. So, negative 1, 3, 3, 13 checks. 1, negative 2, 2, 2 checks. Add, the x's are gone. Y plus 5z equals 15. And this is number 5 equation. So now we're going to take those two equations, write them down above and below each other. So this is what we're used to solving now. So we're going to eliminate one of the variables. And the easiest one to eliminate, as a 4, I need a negative 4. So I'm going to multiply this one by 1, this one by negative 4. When you multiply by 1, you get 4y plus 4z equals 12. You multiply by negative 4, you get a negative 4y minus 20z equals negative 60. Draw a line. You eliminated the, notice we took these two, we eliminated the y's. And so we got a negative 16z equals negative 48 divided by negative 16. And z equals 3. Now, since we got z is 3, go back into one of these two equations. Which one? Well, this is the easier one, because if I put 3 for z in, I'm solving for y, so I'm going to sub 3 for z into number 5. Notice number 5 is y plus. So I have z, y is one variable, so it's easy. So putting 3 in the place of z is easy to solve. So now I have y is 0. Okay, that's okay. Don't have to be you could have fractions, you could have, anything at all when you're working with these numbers. And let's see, I'm going to sub z 3 for z and 0 for y into. So I have two values. I'm going to go back right up to the top, and the easiest one to do is number 1, because there's a 1, a 1, and a 1. So I'm going to sub it into number 1. So x plus y plus z equals negative 1. So z is 3, y is 0, and we're trying to find what x is. So x plus y is 0, z is 3, x plus 3 equals negative 1, x equals negative 1 minus 3, x is negative 4. So we have the three values. So the solution, if you want to go with x, then the y, and then the z, so that's x, y, z as an ordered pair, like in the alphabet. Or you want to write them down, you can write down x is negative 4, y is 0, or z is 3. And that brings us, hopefully you can see the pattern that I'm using for solving a system of equations with three variables, linear. You can see the pattern. If you can't see my pattern and you like my video, click the like button, the subscribe button, and then the notification bell, because there's more videos coming. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel. My YouTube channel is called Math Fully Explained. Thank you for viewing my video. Bye-bye.